An ancient survivor sets out on an invasion course. A path followed by her ancestors for hundreds of millions of years. A horseshoe crab. She spent her year trawling the Eastern American seafloor. She must be strong for the marathon ahead. She faces danger at every turn. Frantic suitors, fierce storms, bloodsuckers, even alien abduction. She'll need all her ancient hard-learned skills to survive. "150 million years ago, dinosaurs stalked the land, while sea monsters rule the oceans. Creepy crawlies forage on the seabed. Then, 65 million years ago, disaster. An asteroid destroyed 85% of life on Earth. But the horseshoe crab survived. A bit of prehistory still in our midst.
They connect me with the past. I mean, you figure the dinosaurs saw the same creatures that I'm seeing.
They may be ugly, clumsy, weird, but horseshoe crabs have their own special fan club.
They've grown on me. They really are very prehistoric looking and just cool.
People assume you can't connect with an animal, but if you spend a lot of time with an animal, you start connecting with it.
They sound a little corny, but have their own personality.
Our female looks like a flying saucer. Under her helmet-like shell, she has 10 jointed legs, mostly used in walking. But the front pair are pincers for grasping food and stuffing it into the middle of her body, her mouth. A scavenger, she'll eat pretty much anything she finds. Algae and small shellfish are favorites. She's not a fierce hunter, taking only creatures small enough to crush with her weak claws. Getting enough food is vital. Her body is busy, mass-producing eggs. Her annual breeding season is right now. She'll need 80,000 eggs ready to lay by the time she gets to the shore. But her greatest secret is her blood. It's blue.
I love that they have blue blood. I've never seen a creature with blue blood before. I think that's just too cool.
Our blood is iron-based. Iron carries the crucial oxygen round our bodies. Iron makes it red. Horseshoe crabs are different. They use copper, and the result is glistening blue blood.
Thank you, sweetie. I'm sorry. I know you hate this. Sorry, sweetie. Can you pat her dry?
Turning science fiction into fact, Dr. Carmela Cuomo explains to her class of marine biology students just how vital this blood is.
And I know it doesn't look blue to you.
So this is what the fuss is all about, this little vial. The blue blood in here is what the horseshoe crab gives to us. Without it, your medicines wouldn't be safe. With it, you can rest assured when you take your pills.
The magical ingredient is LAL. Horseshoe crab blood is full of it.
Limulus amoebocyte lysate is a component of the blood. It clots in the presence of one cell of gram-negative bacteria.
So testing with LAL can show if medicines or equipment are safe for us.
So you actually owe a great deal of debt to the horseshoe crab, because anything you've ever had, any pill you've ever taken for medicinal purposes has been tested with LAL.
We really need them. So why isn't there a monument in every town? Most of us have never even heard of them.
We are really indebted to these creatures, these ugly little creatures, but I think they're beautiful. These ugly little creatures have blue blood that has just been so precious to the people in the world.
I'm someone who has, like most of us, has taken medications. I have a plate and 6 screws in my ankle and all of this. The purity of all of that, my health has been safeguarded by the blood of this lovely little animal. It's just an amazingly awesome animal that is usually overlooked and kind of taken for granted. Thank you. You can look, now you think it's bleeding from the top, Nick?
To students, this is new science. But a few miles away, a timeless scene is playing out. Our female continues her epic journey. Light sensors in her tail help keep track of the light cycles. The moon is full and the tide is right, the annual cue she has been waiting for. Millions of her kind share the urge, the frantic need to mate. The males have arrived first, lying in wait for the main gig. Way before the dinosaurs walked the earth, this same drama was playing out. "450 million years ago, the great-granddaddies of horseshoe crabs foraged the Paleozoic seas. With them, their close relatives, the trilobites. There isn't much competition, and they're among the most successful creatures around. It was a world we can never see, but we can learn from fossils. Some trilobite fossils were bizarre, contorted, looking as though their heads had been torn off. A mystery for paleontologists to solve.
Trilobites are really ancient, and unfortunately they are completely extinct today. So I have to get the analogy from some other organisms. And horseshoe crabs are closest living relatives of trilobites.
Just like horseshoe crabs, trilobites had to shed their tough armor plating as they grew. But while the new shell was soft, they were vulnerable. The missing piece of the puzzle.
They buried themselves into sediments in order to avoid predators.
Perhaps friction from the sand helped them to wriggle free, and the underground bunker gave the fresh armor a chance to harden.
Everyone likes soft-shell crab. It's tasty and it's kind of soft. They didn't want to become food, so they avoided predators by burying themselves into the sediments. The trilobite group became completely extinct at the end of Permian. That's about 245 million years ago or so.
But not the horseshoes. Their formula for survival was well developed even then. Turbulent times. Earth's atmosphere changed. Land masses shifted. Another mass extinction. This time, 95% of marine life was wiped out. But once again, the crabs survived.
When I look at the horseshoe crabs, I look at them as ancient mariners. They crawled on the sediments under the feet of brontosauruses, and when I take a look at that, I get a sense that I'm looking at Earth history unfolding right before me.
200 million years ago. This is the Jurassic, the age of the dinosaurs. Other familiar life forms are showing up. Crocodiles emerging from the swamps. We call crocs living fossils, but they're new kids on the block compared to horseshoes, and they were probably the least of the crab's worries. Plesiosaurs, giant marine reptiles, cruised the reef. Fish eaters with small heads. They struggle to penetrate the horseshoe's armor plating. Ichthyosaurs, the reptilian equivalent of dolphins, use their large eyes to spot prey in the murky water. But these are incredibly dangerous seas, where the hunter becomes the hunted. Some marine reptiles are gigantic. Liplorodon is 25 meters, as long as 2 buses, with an appetite to match. Ichthyosaurs take shelter around the reefs. It works for crabs as well. A terrifying, primordial world full of surprises. 65 million years ago, another disaster loomed, threatening to wipe out all life on Earth. An asteroid delivered its devastating blow. When the smoke cleared, the dinosaurs had gone, along with 85% of life forms. But not the horseshoe crabs. So what is a horseshoe crab? First off, it's not a crab. The horseshoe's loyal fans, the Crab Club, know they are actually closely related to scorpions and spiders.
Look at how cute you look. It's very funny because I really do not like spiders at all. I am not a fan of arachnids. And yet, it's inevitable when you look at them from underneath that you see that she's really a spider. She's tucked away about it. One of the things that you can't escape when you look at these animals is that they are not your ordinary looking animal. This front area is called the prosoma. This area is the opistosoma. And then the long tail is called the telson.
The horseshoe crab is a simple organism with a lot of extraordinary adaptations, perfected by hundreds of millions of years of fine-tuning. The slick design continues inside the shell.
What's really cool about the horseshoe crab is how large the heart is. It's almost the entire length of the animal's body.
The enormous heart beats 32 times a minute, half the speed of ours. It opens in 8 directions and uses valves to keep the amazing blue blood moving from the gills to the legs and main organs. There's a simple gut and a brain shaped like a gear wheel. The finger-like structures carry nerves into the creature's legs, which can smell food and control the most extraordinary eyes.
They have many, many eyes. The first set of lateral eyes, they're on either side. She's got a pair just like that, and because she's so old, they're kind of encrusted. And then they have right behind them, and you can't see them anymore, something that's called vestigial lateral eyes.
Like insects, the horseshoe's eyes are compound. There are 1,000 individual facets, all sending back a separate image to the brain. The main ones seem to pick out the shapes of other crabs. Males use vision to choose mates. The smaller eyes are more sensitive to ultraviolet, useful for monitoring the moon.
And then they have another set of eyes in the front and an endoparietal photoreceptor, basically, and right in the middle. They have 2 others underneath, and then they have another set over here.
These underneath ones have a unique function. She can still orientate herself when upside down. She can even sense light with her tail.
They have a string of photoreceptors down their telson.
Like all insects, she wears her skeleton on the outside. And it's not just a hard shell, it's sensitive to its surroundings. The all-concealing armor looks cumbersome, but in fact, horseshoe crabs are remarkably bendy, almost acrobatic. Their structure looks simple, but is highly complex. There are 750 muscles in the body. They can walk, fan their gills, and do remarkable gymnastics, very useful at sea. Foraging on open seabeds is challenging, and the crabs must avoid being flipped by the current. Only their tails can save them.
Their tail, the telson, a lot of people think, like, is it sharp? They're gonna stab me with it. Do they use it as a weapon?
It's not a weapon. More a pole for leverage.
It's just there to help them move and flip back over, and I think that's really cool that it's not what we first think of as being sharp and, like, aggressive. They're really docile.
At the mercy of ocean currents, many small marine creatures have to go with the flow, but not these crabs. Now the telson becomes a drill to bore into the sea floor, a built-in anchor. The armor plating can repel small predators. But when a larger hunter threatens, evasive action is the only answer. The tactic works. Rays are a bigger threat. They patrol the seabed, scanning the sand with electroreceptors. Their mouths are on the underside of their bodies, so they can dig out hidden prey. A narrow escape. With the coast clear, she can resume scavenging.
Now, this is her mouth. And she uses these two tiny pincers here to push food into her mouth.
It's these little arms that reveal her family ties. Only spiders, scorpions, and horseshoes have these little feeding arms.
What's really crazy about the brain is that when the animal eats, it goes in the mouth. It has to go through the brain before it can get into the stomach and go out the GI tract.
Talk about having food on the brain.
And now, horseshoe crabs come in two sexes, just like people. And the way you tell the difference is female horseshoe crabs, their first pair of walking legs looks exactly like the rest of the walking legs. On males, this first pair look like little boxing gloves, and that's because they use them to clasp the female when they're reproducing.
The inside of the female horseshoe crab is just loaded with eggs. She's got 90 to 100,000 eggs, fills out her whole body.
She really is an egg factory. Thousands of them float inside her until she is ready to lay. And that time is near.
On their legs, the horseshoe crabs have an amazing number of chemoreceptors, which is what helps them basically to smell, if you think of it that way. You don't smell with your legs, but they do. And then back here, unlike fish and other organisms that live in the marine environment that have gills, these animals have something called book gills. And look at how nice she's cooperating right now. She's actually lifting her book gills up. They look like the pages of a book. They fan up and they fan down. And that's how the horseshoe crab respires. That's how they breathe.
She can survive for days out of the water, as long as her gills are kept wet.
So in many ways, she really does look rather prehistoric. And when you look at her from the underside, she definitely looks like a spider and not like any other crab that you see.
It's spring, and all adult horseshoe crabs are responding to a mysterious cue, a trigger hardwired into their ancient brains. Among them, our female, well-fed and ready for action. Once a year, when a full moon stimulates those UV-sensitive second eyes, and a high tide gives them a clear run at the beach, the stage is set for a giant romantic rendezvous. The invasion begins. For our female, the finishing line is in sight. Navigating using her many eyes, she arrives just behind the breakers. She swims into an ambush. Male crabs have been lurking, ready to jump any females that come near. Our female hides in the seagrass. She won't give in to the first male that comes along. The females are much bigger than their suitors, a whopping 35 centimeters across. The males get